Hello guys, welcome back to my video lecture series on the Black-Scholes European option pricing model derivation. So in the past few videos we were talking about a financial asset, or the underlying financial asset, and how to model it as a function s of t. And essentially what we came up with was that we could use a geometric Brownian motion model such that we can capture every point in time, the stock price at every point in time, as a probability distribution. And the way this is represented is as such. We have ds, and obviously this is going to be in differential form. So we have ds is equal to mu s dt, which, as we talked about, this is going to be our drift term, plus a random shock term, which is sigma s dw. And just keep in mind, dw is the infinitesimally small increment of the Wiener process, which could also be thought of as an incrementally small increment of Brownian motion. Cool. So with this model, we have two free parameters. We have our mu, which is going to be our mean returns, and we have sigma, which is going to represent our volatility. And these are parameters that we can calibrate, or essentially we can choose. Cool. And a very important point is when we're using this model, it will give us an educated, almost approximation of future price distributions if mu and volatility are chosen properly. So essentially what it's saying is it's not a perfect model, but it is a very helpful model to use when we're forecasting stock prices or wanting to do some degree of risk management, for example. Now that we got that out of the way, we can really talk about what a financial derivative is. So essentially what a financial derivative is, and there are many types, but we're just going to be focusing on calls and puts in this video lecture series. But it's essentially a contract whose price is derived from an underlying financial asset or stock. So again, a financial derivative also has a price, which let's call V, and then that has some correlation with our stock price. It is essentially derived from our stock price. And this is why we talked about financial assets first before going into financial derivatives. Because, like I said before, the financial derivative depends on the underlying financial asset that we're analyzing. So in this video, I'll just give the basic definitions of what kinds of financial derivatives we're going to be analyzing, specifically calls and puts. And in the next video, I'll go over a more graphical representation of how these contracts may play out in the real world. But essentially, we're going to be focusing on calls, and we're going to be focusing on puts. So essentially what a call is, from the seller's point of view, could be thought of like this, almost like a game. At time t, which is a final stopping time, if our stock price as a function of time, or our true stock price, is greater than or equal to K, which is a strike price, so I'm going to write that. K is called our strike price. Then I will sell you 100 shares of the underlying stock at $K. Now, the seller is essentially selling this contract or this game to a buyer, and the buyer must pay a price V, which is essentially our derivative price, or you call it the premium, to enter this contract. So again, the seller is looking at a stock price and is setting a K strike price, and if that stock price were to go above or at that strike price, he will sell the buyer 100 shares at that K strike price, but from the buyer's perspective, he has to pay a certain premium to enter this game or this contract. And puts can be thought of in the same way. So in the seller's perspective, at time t, if S of t is less than or equal to the chosen strike price K, and again I will say K is going to be our strike price, then I will buy 100 shares from the buyer, obviously, of the stock price or the stock S at $K, and from the buyer's point of view, again, he will have to pay some V premium to enter this contract. And as you can see, this entire contract depends on what happens with the stock price relative to the strike price chosen. Now, again, to reiterate how puts work, so at a final time t, if my stock price goes lower than a chosen strike price, the strike price is a constant, then the seller of this position, the put position, will buy 100 shares from the buyer at that K strike price. And the drawback for the buyer is that he has to pay some kind of premium to enter this contract. And just as a little bit of foreshadowing, this V, the fair price of V is essentially what the Black-Scholes tries to solve. And in the coming videos, I'll explain that, and specifically in the next video, I will draw out a graphical representation of how a call contract and a put contract will play out for a buyer and seller for various final prices of an underlying stock price.